Hi everyone, I just wanted to do some examples of problems for you today. So we're going to start with this problem that says f equals k times q1 times q2 over r squared. And the problem is asking me to solve for r. That means I need to rearrange the problem so that I can get r alone. So the first thing I need to do is get rid of this fraction on this side. And to get rid of the fraction, I'm going to multiply by whatever's on the bottom. Whatever I do to one side, I have to do to the other. These cancel out, and now I have f times r squared equals k times q1 times q2. Remember, my goal is to get r alone. So the next thing I'm going to do is divide by whatever's next to r. So I'm going to divide both sides by f. Now I have r squared equals k times q1 times q2 over f. And I only have one more thing to get rid of, which is this exponent of 2. So to get rid of that, I'm just going to take the square root of it. Whatever I do to one side, I have to do to the other. That leaves me with r equals the square root of k times q1 times q2 all over f. The next problem asks me to solve this equation. So the first thing I notice is that I need to get rid of the denominators, or get like denominators. So in order to do that in this equation, I first must factor this quadratic. If I factor this quadratic, I'm going to get x plus 5 and x minus 3. If I were to do the airplane method, just as a reminder, I'd put this number on the top and this number on the bottom, and then I would see what can I multiply to equal 15 but add or subtract to equal 2. And that's where I got those numbers from. My magic numbers are -3 and 5, which I put right here. Something else that you want to note when you have equations like this is that often when you factor this, it will equal these other two. So keep that in mind because that's going to be very useful. Alright, so now that we have factored this quadratic, I need to multiply by my biggest denominator. And in this case, my biggest denominator is the quadratic that I factored. So that's what I'm going to multiply everything by. Whatever I do to one side, I have to do to the other, and I have to do to every item in the other side. Okay, so what happens on this first one is that all of these cancel out with all of those. Because I have the same thing on the top and the bottom, it's just going to cancel out and I'm left with 6. On this side, I notice that I have an x plus 5 and an x plus 5. So those are going to cancel out, but the x plus minus 3 is going to stay. So now I have 7 times x minus 3. And then over here, I notice that these two cancel out, and I'm left with 2 times x plus 5. Next, I need to distribute these numbers into the parentheses. So I'm going to bring down the 6. 7 times x is 7x. 7 times -3 is -21. 2 times x is 2x. And 2 times 5 is 10. Now I'm going to get my x's on one side of the equation and my numbers on the other side. So I'm going to take this 2x away. So I have 6 plus 5x minus 21 equals 10. But now I notice that I have two numbers over here. So before I can move these numbers to the other side, I have to combine like terms. A positive 6 and a negative 21 are going to equal a negative 15. So now I'm going to add 15 to both sides. And in my last step, divide by whatever is next to x. And there's my answer. X equals 5. Alright, so in this problem, I have the fifth root of 27 times x minus 2 equals 3. My directions are to solve the equation. So the first thing that I need to do is get rid of that fifth root sign. So in order to get rid of a fifth root, I have to raise it to the fifth power. Whatever I do to one side, I have to do to the other. That's going to cancel out that fifth root, so I'm just left with what's underneath it on this side. And now I have 3 to the fifth power on this side, which I'm going to work out on my calculator. And 3 to the fifth power is 243. The next step is distribute the 27. Now I'm going to bring my number over to this side. I get 27x equals 297. Divide by whatever's next to the x. And x equals 11. And I am using my calculator as I do this. Alright, again I have been given an equation. The surface area equals 6 times a squared. And they ask me to solve for a. So that means I've got to rearrange the equation and solve for a. The first thing I'm going to do is get rid of whatever's next to a, which is this 6. It's being multiplied, so I'm doing the opposite, which is dividing. Whatever I do to one side, I have to do the other. Now, a is still not alone, so that means I've got to take the square root. Whatever I do to one side, I have to do the other. That gets rid of my squared, and this is what I'm left with. Alright, this equation says the area of an equilateral triangle is given by the formula a equals the square root of 3 over 4 times s squared. Which formula represents the length of an equilateral triangle side, s, in terms of the triangle's area a? So all that means is solve for s. So I'm going to solve this equation for s. That means I've got to get rid of everything that's next to the s. So the first thing I want to get rid of is this fraction. In order to get rid of the fraction, I need to flip it and multiply by it. Whatever I do to one side, I have to do to the other. On this side, those two fractions will cancel out. And on this side, I am left with 4a over the square root of 3. And it equals s squared. And hopefully you're catching on to what we do next, which is to get rid of this squared sign, this exponent. So in order to get rid of the exponent, I'm going to take the square root. Whatever I do to one side, I have to do to the other. That leaves me with just s on this side, and on the other side I am left with 4a over the square root of 3. Alright, the next problem tells me that a student has solved his work, and this is the work that the student solved. They're asking me which statement below is true. So one of the choices, of course, is the student's work is correct. There's other various choices. So I'm going to show you how to check the student's work, and then we're going to go back and plug in these two answers that they got and see if they both work. So first I'm going to go up here to the top and I'm going to check if they've solved this equation the right way. So the first thing they have to do is subtract 3 from both sides, and I see that they did that. Now they're trying to get rid of the square root sign, so they squared both sides. Okay, that's correct. Now they're going to move this information over to this side. First, let me show you how they got this quadratic right here. So x minus 3 squared looks like this. So they just wrote it twice and then foiled it, and that's how they got that quadratic. So now they're going to subtract this information, or add, whatever. They're going to do the opposite of whatever the sign is, so that they have 0 on this side, and then they combine like terms on this side. So far it's correct. They've done everything correct. Now they are factoring this equation. So if we airplane it, I know that 1 times 20, 2 times 10, and 5 times 4. So in order to get a positive number here and a negative number here, both of these have to be negative. So negative 2 minus 10 equals 20 if I multiply, and negative 12 if I subtract. So they have done this correctly. So far everything looks good. Then what they do is they set this equal to 0 and this equal to 0, and they just solve each equation for x, which they did correctly. Okay, so everything looks good. So I'm tempted to check that box that says the student's work is correct, but I need to check if both of these answers are solutions for this original problem. So what I'm going to do is I'm going to plug 2 in to this equation everywhere that there's an x. So I'm going to say the square root of 6 times 2 minus 11 plus 3 equals 2. Remember, I'm plugging 2 in wherever there's x. 6 times 2 is 12. Now I'm going to solve what's under here. The square root of 1 plus 3 equals 2. I'm going to erase some of this stuff. And the square root of 1 is 1. So now I have 4 equals 2. Does 4 equal 2? No, it does not. So this is not a real solution to this problem. Let's see if 10 is a real solution to this problem. So I'm going to plug 10 in everywhere there's an x. So the square root of 6 times 10 minus 11 plus 3 equals 10. So 60 minus 11 plus 3 equals 10. 60 minus 11 is 49, plus 3 equals 10. Square root of 49 is 7, plus 3 equals 10, and 7 plus 3 is 10. 10 equals 10, so that is a real solution to this problem. So one of my choices is that the student included an extraneous solution of x equals 2. The correct solution is x equals 10 only. And that's the one that I would mark for this answer. This is my last examples for you guys today. So this question has 4 different equations for me to solve and then match up with answers that are already given on the screen. So it's a matching. So I'm going to show you how to solve these problems. Remember, the first thing we want to do is get rid of the square root sign. but I have a fourth root, so that means I have to raise it to the fourth power. Whatever I do to one side, I have to do to the other. That's going to cancel out that fourth root, and I'm just left with x to the third equals 64 to the fourth. On your calculator, you're going to enter that 64 to the fourth power, and I get this really long number. All right. Now, I have to get rid of this exponent of 3 on this side because I still want to get x alone. So I'm going to take the cube root of both sides. And that'll get rid of the 3. I'm left with x on this side. Now, in order to do a cube root on your calculator, you're going to put 3 first. That's this 3 right here in your calculator. You're going to hit second, and you're going to hit the caret button that you use for exponents. Then you're going to enter the long number 16777,216, and the cube root of that number is 256. So I would match this equation up to 256. And let's do this one just so you have a good idea of how to do these. So first thing I need to do is get rid of that cube root sign, so I'm going to raise everything to the third power. Now I'm left with x to the fifth equals 32 to the third power. 32 to the third power is 32,768. And to get rid of that fifth root, or the fifth exponent, excuse me, I'm going to take the fifth root of both sides. That's going to cancel out that exponent. And the fifth root, remember in your calculator you're going to put 5, second function key, hit the caret, and then enter that number 32,768. And the fifth root of that number is 8. So I would match this equation to the number 8.